Okay, so today we're doing the second day of chapter 6.5. This is all solving by factoring. Good news, you've already done this. We did it sort of as a mini lesson, like a side lesson when we learned excluded values. So we called it the zero product rule. Do you remember what the zero product rule says? Yes.
All of the equation equals to 0.
So if you have two quantities that are multiplied together and they result in a 0, one of them has to be 0, right? So you're going to, like he said, set each part, all the parts have to equal 0. So x plus 2 from the first set of parentheses equals 0. And 3y, did I say x plus 2?
Yes, you did.
I meant y plus 2, silly. So yes, anytime I say x, just pretend it's whatever variable's on the board. Or the 3y plus 5 equals 0. So we need to solve both of these, and then those will be our two solutions. How do you get y by itself in that first equation? You just subtract 2 from both sides. And y equals negative 2. Boom. That's an answer. How would I solve the other equation? Subtract the 5. Then divide by 3. And y equals negative 5/3. That's it. So I don't really care if you want to leave them separately and just circle two answers or if you want to write them together. Don't put parentheses around it. Some people, when they have two answers and a comma in the middle, they want to make it an ordered pair. This isn't an XY value. In this case, they're both Y's, so leave it be. Any questions? Okay. Number 2. Yes. What do you mean? It's already factored out.
Or, multiply everything by 3.
No.
Or to just make everything equal to 0.
Yes. So sometimes in these sorts of problems, students want to just keep going in circles. Like, oh, I see 2 sets of parentheses. I'm going to double distribute. Or, oh, I see a 3 in front of parentheses. I'm going to distribute the 3. You're doing the complete opposite of what we want to do. Okay? We want to get it into factored form. It's already in factored form. Don't distribute now because you'll just undo all the work that was already done for you. So leave it in factored form. We want it to be all multiplication equal to 0. Why?
Easier.
Why is it easier?
Find out the excluded values.
And excluded values is when we have fractions. Why do we want it in factored form? Why do we want it as a multiplication problem? What's the rule called? The zero product rule. You can only use the zero product rule if you have a product. What does the word product mean? Multiply. This rule only works when you are looking at one side of the equation that's all multiplication and the other side of the equation that's equal to 0. Okay? So now I can make each of the factors, including the 3, equal to 0. So 3 equals 0. Does 3 ever equal 0? No. If you have something that doesn't have a variable in it, you still need to take a moment and consider it, but you won't get a solution from that equation. Now, if it was 3x equals 0, then you would get a solution of 0. So you got to be careful with that. When there's no variable at all, though, that's not going to give you anything productive. The other ones will, though. So x minus 1 equals 0, x plus 1 equals 0, x plus 4 equals 0. Okay, we're going to solve these. How do I solve x minus 1 equals 0? You add 1. And you get 1. Then you subtract 1. And you get negative 1. And then you subtract 4. And you get negative 4. You'll start to notice this pattern, right? The only thing with the pattern, like if you're noticing, hey, it's always just the opposite. If you have a number in front of the x, you'll have to divide by that. So just be on the lookout for it, okay? Like on the last one, how we had 3y, and then our answer was divided by 3, you know what I mean? So don't go too quickly. Here are our 3 solutions. Again, I don't care if you write it in 3 separate spots and circle each of them, or if you write it as a list. Good by me. Questions?
Would we just not write an answer for 3 equals 0? Or just did he put the...
Yeah, so that doesn't give us a solution because there's no x.
You don't write anything?
Nope, you don't need to write anything. There's no x to isolate. What are your questions? Okay, next. All right, here's where we kick it up a notch, and we haven't looked at any like this yet. It's called the what product rule? Zero product rule. So I need to make one of the sides of the equation a 0.
We're gonna move 7x.
And so we're going to move the 7x over with the x squared. If you're not sure which side to go with, always keep your largest exponent positive when you can. So like if I would subtract this guy, get everything over here, I'd end up with a negative x squared. That just sort of complicates things more than we need to. So leave it over there, get the 7x. How do I get a 7x to the other side of the equal sign? Subtract. So I'm going to subtract 7x from both sides. Now I have something that's equal to 0. Is it written as a product? No. So now what? Thank you. Yes, we can do GCF and factor out an x. All right, then what? X minus 7 equals 0. What else equals 0?
X.
The x, yep. Don't forget about the x out front. How do I isolate the x, though? It's already isolated, right? That equation is solved. 0 is one of your solutions. What about the other one? Add 7 to both sides. 7 is one of your solutions. What are your questions on this? And again, if you want to write them in one list, that's fine. Ooh. Yes, so there's no such thing as the 25 product rule, right? We got to get it equal to 0. So I'm going to subtract 25 from both sides. This is what? Dots. Very good. Dots and a 5. So x plus 5, x minus 5. Good. Each of those equals 0. And then you just get negative 5 and positive 5. And there you go. You guys want to be extra fancy?
No.
If you want to be extra fancy, you got to put one pinky up.
No.
And you can write it like this.
Oh my god. Really? You see, that's what she told us to do in August.
Yes. So that symbol means plus or minus 5. So the positive 5 or the negative 5. The pinky is optional. But you can write it any way. You can write it with 2 x's. Circle both of these so I know those are your 2 answers. You can write it like this. Or extra fancy, you can write it 1, 5. This symbol means I have the positive 5 and the negative 5 both. It's fun, right?
I was wondering what that symbol
A little fancy time? No? Okay. All right, next.
Oh.
I could just put it inside of it.
Okay. Is it the -3 product rule?
Nope.
No. It's the 0 product rule. So we got to move that 3. How am I going to do that?
Add it.
Yeah, it's negative now, so add it, and that would give us a 0 on the right side. Something that hopefully is factorable on the left side. I have a d squared, a d, and a regular number. So what can I do?
It's gonna be MA.
Yes, this is the MA. I'm going to do some work off to the side because a lot of you are still struggling with MA when it's not a 1 right here. So remember, this is 2 times 3. That gives us an M of 6 and an A of 5. What is a combination that multiplies to 6 and adds to 5?
3 and 2.
3 and 2. So we'd have x plus 3 and x plus 2. What do I do with both of those, though? When it's not a leader of 1, you have to do the bottoms up step. You have to divide by 2. This one doesn't reduce, so I move the bottom up. That's where the 2d plus 3 came from. Back here, 2 divided by 2 is where the plus 1 came from. A lot of you are struggling with this type of factoring. So when this PowerPoint was written, we assumed you guys would be able to factor a trinomial, but I'm seeing from your test that that's still something you're struggling with. Don't forget, we don't always call it the MA method, we call it the bottoms up method. And this is why. You got to remember the bottoms up step. Okay? The factoring work is about to disappear. Are we good? Okay. Now, d plus 1 equals 0, 2d plus 3 equals 0. This is where I caution you, don't get happy, a little extra opposite happy, where you just change the sign. The answer is not -1, -3.
No.
I agree with the -1, right? You minus 1, minus 1. What's the problem back here? Yeah, you have a coefficient in front of your d. So subtracting 3 is the first step, but it's not the only step. Then you divide by 2. So I wouldn't call this a hard equation, but a lot of students will drop off that 2 just on accident. Don't be that person. So again, you can list them or you can leave them like that. Yes.
Would you penalty points if you actually accidentally change the variable in the problem?
No.
Because I kept doing accidentally.
I honestly probably wouldn't even notice. Did you guys hear the question? If you accidentally made them X's instead of D's, that's fine. I know in classes like chemistry or in when we start working with more than one variable in a problem, X's and Y's, you got to be a little more careful. But for this particular problem, I'm more concerned with the -1, -3/2 than what variable you're using. All right, I'm going to call this the final problem.
Yay.
Subtract 20x. Where shall I write the 20x? In the middle. To factor, you want the x squared term, then the x term, then the regular number. We call those constants. We want it like this.
Does it have to be like?
Yes, it has to be like that.
I'm not gonna remember that.
Okay. MA. I'm going to do the whole process for you. Multiplies to 100. Adds to.
I was thinking about 10 and 10, but
-10 and -10.
-10 and -10 will work. Yep. Okay. Here is where a lot of you would just be done. Whoop.
Divide by 4.
No. Bottoms up. I almost sang that rap song. I won't. No one needs to hear it. Okay. What now?
You divide by 4.
You got to simplify those, right? They're both divisible by 2. But now I still have fractions.
Oh shoot.
So now what?
It's going to be 2x.
Now you move the bottom up. Sometimes you can simplify and do bottoms up.
That sounds interesting.
So 2x minus 5 times 2x minus 5 equals 0. Yeah, you can write it both times if you want.
We could just write a lot.
But it's going to give you the same answer. You can't really have the same answer more than once. So just solve one of them. So add 5. So I have 2x equals 5. Then what?
5 by 2.
So x equals 5 over 2.
Yay, we're done.
Right on time.
What are your questions? We good? All right, let's get homework going, go over your tests, and then I will send you on your way.